Today's topic is load flow study of power system. This is a very important kind of study, and I will explain you in full detail that what is the data required whether you perform this load flow study on Syncol or PSS or ETAP. The data will remain same. As you know, my 99% video lectures are based on my practical experience with these items or subjects which I am uploading on the YouTube channel Abrar Electrical World. I do take help from the literature, but all the lectures are blend of theory and practice as well. So I did my first load flow study in 1975 in United States, and that was about the network of Karachi Electric Supply Corporation, and also I performed the power system studies, all kind of studies I will show you here for Saudi Arabia as well. So all these my lectures are based on the practical experience, and since then I have been doing system studies very regularly, and at least more than 15 projects, final year projects I have conducted in NED University on the topic of the power system studies with the final year. So let's start this study. Now these are the major kind of system studies. Actually this slide should have been the first one, but I don't know why this has become the third one when I was finalizing the studies, this lecture. Anyway, see, the major power system studies conducting are steady state, dynamic state, and the transient state, then the short circuit study and the load flow study. I have already taken up in detail the transient state stability, power swing. I have uploaded at least 10 lectures on that because that is one of the most difficult area of system study. I have conducted that study too many times. Now short circuit study I will upload independent lecture. I will not mix up it here, but today's the topic of this one is the load flow study, for which I have already shown you the data to be collected. That what data do you need for the data collection? Now the data collection needs all the parameters of the overhead line cables, and when I say the parameter, you know, I have written here resistance, reactance, capacitance. Then when do you conduct the load flow study, which is one of the studies conducted under power system studies? This is also sometimes known as the power system steady state stability, because in this case you do not assume any faults. However, you assume contingencies like outage of one line, outage of one transformer, outage of machines, etc. They are deliberately done, and that is known as the contingency. And if you have 10 lines or 50 lines and you remove one line at a time, then you will call it n-1 contingency. N will mean the total number of that item. Suppose you have 100 transformer or 100 machine or 50 machines, and you are taking one machine at a time, you will call it again the n-1 contingency of generating plant or the transformer or the line. So one by one you conduct the study, taking out important lines you select, and there can be two cases. That in one case you have a network and there is some addition going on, and second is that you want to build up a network and you know the locations of the various loads, and you know the quantum of the load, you know the power factor of the load. So all those things will be required. So there can be two kind of situations when you conduct the study. Number one, you are doing it for planning a completely new power system network for a new city coming up. or you are conducting a load flow study on the existing network with the extension, like you are connecting a wind turbine to a NTDC system, then you will conduct a study of load flow study, that is the steady state stability. I will tell you that what results do you get out of these studies. So these are the data required. You see, there are hell of a data required. The location of the power plant is required, capacity of the generator, reactances and location, capacity of the capacitors, position of the capacity of auto transformers, voltage ratio of all the transformer. So all these data is required when you need to conduct the. Now what will be the outcome of the load flow? So outcome will be that when you will get the result, you will get all these results, that the active reactive power flow, direction of the active power flow, direction of the reactive power flow, voltage on all the buses which you call them nodes, then power factor, losses, voltage drop, everything you get. And one very famous thing I have been talking about, the bus angle, also you get from the load flow study. So load flow study is basically done to check whether the system is stable or not in a steady state condition when there is no fault. That is, do you assume the outage of the line, you put off a line, disconnect a line, disconnect a generator, but you do not create a fault. Fault is something very different from the intentional outage or the switching off a generator, alternator is missing, a transformer is missing, out of service, under maintenance. So those are the contingencies. So don't mix up contingency with the fault. Fault means a heavy fault current. That is a different kind of study. That is the transient state stability and the short circuit study. What else you get? You get the future requirement of generation, because in this load flow study you leave one bus as an infinite bus who can absorb all the extra power, because you do not know exactly that how much generator and where the generator will be required. From the load flow study, actually you will be able to pinpoint that, because you know the load and the location of the load. So you, from this location of the load and the quantum of load and the length of the lines, load will be distributed all over the power network, and the share of each of the generator will be given to you. And in the end, you find out that some generator is overloaded, then you will have to suggest some additional capacity, or you will have to suggest another power plant, or you have to suggest some lines, you have to give some proposal so that nothing is overloaded. So for the load, from the load flow study, actually you have to ensure that the system runs properly and all the parameters are within the limit: frequency, the voltage, the bus angle, the power, active power, reactive power, loading of the line, losses, everything is within the limits. So, and then after all, when you know the loading, etc., then you suggest that the duplicate lines should be placed, installed at some places, or the FAC devices may be installed in the modern systems, so that you control the reactive power and you reduce the loading of the line. Or I have already explained in a video lecture about the weather adjustable transmission lines, so you can try those things as well. So these are the outcome of the load flow. These so many results, so many, and then you get the drawings from the network, from the software. You get the drawings. And would you believe that when I conducted the first study in 1975 in USA, after getting the result, which were in tabulation form, all the magnitudes and angles and everything, load flow given, we had to prepare the drawings manually on the large imperial size sheets we use in the engineering colleges. And then those drawings were sent to Saudi Arabia from USA after studying the networks of all the cities almost in Saudi Arabia, because 1975 was the year when the Saudi Arabia has started growing to the EST network. So that study I had a chance to conduct, but everything drawing And all the drawings of imperial size, they were drawn by the scale and the pencil, and everything was written by me and other team members by hand. All the arrows, magnitude, angles, everything was written by hand. This is just to inform you that I have the first hand and the hands-on experience of conducting all kind of system studies. Thank you very much. I think this will be useful for you, and I hope you will enjoy this. Thank you very much.